Howdy, everybody. Hope you're doing well wherever, whenever you are. It's day 25 of Advent to Code 2015. We're on the last day. Yesterday's I solved okay. There's definitely a better solution, and looking into it, I think we'll do another video on it just to make it better, because I think we can do another solution, and understanding why the DFS, the depth first search solution, worked. I think it's going to be interesting. So anyway, we'll definitely do some recaps of these. Talking about nom too, I think will be helpful, like when to use it and when not. I have some ideas of things to improve, so we'll do a recap video where we kind of go over a bunch of stuff after this. But anyway, with this, I think let's just do day 25, right? Get it over with. Here we go. It is Let It Snow. Merry Christmas. Santa is booting up his weather machine. Looks like you might get a white Christmas after all. The weather machine beeps. On the console of the machine is a copy protection message asking you to enter a code from the instruction manual. Apparently it refuses to run unless you give it that code. No problem, you'll just look up the code in the... Ho ho ho, Santa ponders aloud. I can't seem to find the manual. Okay. You look up the support number for the manufacturer and give them a call. Good thing too, that 49 star wasn't going to earn itself. Oh, by the way, I think will only have one part, right? They usually only have one part, but we'll see. Oh, that machine is quite old, they tell you. That model went out of support 6 minutes ago, and we just finished shredding all the manuals. I bet we can find you the code generation algorithm, though. After putting you on hold for 20 minutes, your call is very important to them, it reminded you repeatedly. They finally find an engineer that remembers how the code system works. The codes are printed on an infinite sheet of paper starting in the top left corner. The codes are filled in by diagonals. Starting with the first row in an empty first box, the codes are filled in diagonally up and to the right. Starting with the first row in an empty first box, the codes are filled diagonally up and to the right. This process repeats until the infinite paper is covered. So the first few codes are filled in this order. Okay, so it's like you're doing diagonal ups. I see what it means. You start here and then you go to this one and go up, this one and go up, this one and go up. For example, the 12th code would be written as row 4, column 2. The 15th would be row 1, column 5. Yeah, okay. The voice on the other end of the phone continues with how the codes are actually generated. The first code is 2015-1125. After that, each code is generated by taking the previous one, multiplying it by 252,533, and then keeping the remainder from dividing that by 33,554,393. So to find the code, which ends up in row 2, column 1, start with this number, multiply it by this to get this, then divide by this, which is a remainder of this. That remainder is the second code, which goes right here. Oh, says the voice, it looks like we missed a scrap from one of the manuals. Let me read it to you. You write down as numbers. Now remember, the voice continues, that's not even all of the first few numbers. For example, you're missing the 1 at 7, 1. That would come before 6, 2. This one. Yeah, that's right. But it should be enough to let your... Oh, it's time for lunch. Bye. The call disconnects. Santa looks nervous. Your puzzle input contains the message on the machine's console. What code do you give the machine? Oops. And it is this. To continue, please consult the console grid in the manual. Enter the code at row 3010, column 3019. Okay. So how do we solve this? If there is a math way to do this, it's not coming to me immediately. Like, essentially, think of like the naive approach, which may be what I end up implementing, is you just start here and you can say, oh, I'm going to calculate this one, and then this one, and then this one, and then I go down here, this one, this one, this one, and so on in this diagonal pattern. And you basically just keep going until you get to this row and this column, right? I wonder if in looking at these, I don't want to stare at this eye chart for too long, but like, I wonder if there's any patterns. Like, notice it could get really small, but then it immediately gets bigger again. Yeah, I don't. The problem is you're doing weird math. Like, you might be able to argue. Again, I haven't thought through the math a lot. Maybe there's ways for you to figure out to do some logic with remainders and multiplying. If we have to get there, we can. Yikers. Right? Like, get out a pen and paper and start like putting in some variables and see if we can't like reduce these things. And then see if we can't find a pattern. How to brute force it? 310 times 319. So, like, presumably you had to count to 10 million. I mean, I'm willing to try it. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 and 17. So we say let parts equals input dot split space dot collect. And then we can say let row equal parts 15 dot. I need to trim comma, trim end matches comma dot parse usize 17. Do it for 17 as well. Oh, but it's not a comma, it's a period. Like that. Oh, and we have column So if we say like let R equal I think I want to do them by ones. Because this one is ones based, right? This is row 1, column 1. Then I don't have to do any math. Because what I think I'm gonna do is just like loop through it until I find it. So I'll be like, while R does not equal row and C does not equal call. I think it's actually or, right? While either of those aren't true, do this. (2015) 11/25, is that what it was? Yeah. I guess just for sanity, copy and paste. Okay, so that's the current code. Now I want to figure out what the next code is. And how do I do that? So think about like, if I'm right here, I'm at row 1, and now I actually want to go to row 3, column 1. So I'm at row 2, I'm at column 2, row 1, row 3, 3, 4. So the every time you switch, so when you're right here and you want to like now go to right here, the row becomes the column. Sorry. Yeah, the row becomes the column that you finished up plus 1. So we'll say if R equals 1, row is equal to column plus 1, and then column is equal to 1, right? We start back at column 1. Else, we're going to go up and to the left. So we go from 1, 3. So column increases and row decreases. And then otherwise we just do the math. Multiply it by this. And then code is the modulus of this. What doesn't like about these? Oh, I need to unwrap these. Okay, so what do? We get the row and column. We start at 1, 1, which is this value. Then we say, if we ever get to the top of the row, which we are initially, we want to go to the next row. So row becomes column plus 1. And then we start a column back at 1. And then we slowly move, we do the calculations, and then this part of it moves us up into the diagonals, right? We increase our columns and decrease our rows until we get to row 1. Then we start it all over again and return the code. I think that's it. And there may not be a part 2. We'll see. A negative number, huh? Huh? How would that ever be the case? These two must not be correct. Does this work? I don't remember. Oh, it does. 3010, 3019. How could I possibly ever get a negative number? Oh, is it bigger than a U size? Maybe it's not treating it as a U size. Oh, it thinks it's an I32, so it is overlapping. Okay, that feels better. It does solve very fast too, 57 milliseconds. Okay. Is it the right answer though? It is. You get 1 gold star. Okay, that wasn't too tough, I think. That's part 2. Yeah, there is no part 2, right? The machine springs to life, then falls silent again. It beeps, insufficient fuel. The console reads 50 stars are required before proceeding. 1 star is available. 1 star is available. You check the fuel tank. Sure enough, a lone star sits at the bottom awaiting its friends. Looks like you need to provide 49 yourself. We got it. Star weather machine. Okay, very cool. 2015 day 2015 day 25 in the bag, and the whole year in the bag, right? So is there anything about this solution that we don't like? I mean, I think this one is really good. Overall I thought it was a good year. It's the first year is probably easier than some of the average years. There have been years that have been way hard, right? Especially some days. I think there's been days where I've spent like 8 hours on it or something like that because I just can't find a solution to it. Although I will admit I am not fast with solving these puzzles, so. But yeah, I think this looks fine to me. The only thing that was going through my mind is there might be a faster way to do this, because you can say it occurs to me that like the tracking the rows and columns is really just the iterator part, and you're really just doing this thing some number of times, whatever n is. And so the question is like, given a row and a column, what is that nth thing? So that might be something worth looking up and solving in that respect. Yeah, because I think you could you might be able to do some math and say given the row and column, you know what the length, you can probably find the length of the previous one, and then it's like a triangle number to get to there, and then you just need to know how far you are from the beginning. So you may actually be able to calculate it. So that would be worth doing. I don't know that it's faster than doing this way because you're still doing the for loop, but knowing that number, you then can potentially do I mean, you just do it iteratively. Anyway, I'll look and see. What I'm going to do is go through each of the days and see if there's any like way better solutions than what I came up with, and then compare and contrast them, the ones that are interesting. Maybe not all of them will be interesting, but that's kind of my plan. I also want to like look at the days and see which ones might have been worthwhile to use like a parser library like Nom for, and which ones are not. Again, I'll say with respect to that, I'm starting to feel like for these puzzle solving ones, there's like very few cases where Nom is worth it, because you can just do things like unwrap and boom, your problem solved, right? So anyway, I'll make I think the next video after this one will probably be a recap of all the days, any improvements. Day 24, I already kind of figured out how that DFS worked, and so we'll look at that one. But if there's days you're interested in, I would love to hear about it. Like if there's a day that you don't understand that we can dive deeper into, you have some questions about it, I would love to help with that. Or maybe if you found some solution that's better than one of my days, we'll definitely go through a lot of the comments and try and find those. So that'll be the plan for the next video or two. We'll see how long all of those take to do, but that's kind of the idea. And then I think we'll move on to 2016. We might do some things differently. Maybe we try and do it competitive. So like I just try and do it as fast as I can. I probably don't talk as well when I'm trying to just speed through it all, but we can put up a timer. I don't know if you've seen, but like I built this little timer thing to help me time, put my time cards on YouTube. So anyway, those type of things. If maybe we try some of the days competitive, maybe we review some days. Anything. We'll see. It may also be that what I do is I go look through some of my previous solutions and see which ones were most interesting, and we just focus on those. Like I think part of learning is just doing it. So me doing these 25 days, I think has really been helpful. I've been able to like refine and write some code to help, me feel like, oh, okay, I'm more comfortable solving problems. But part of it too is just knowing the algorithms. Like if you've thought about, oh, I want to be a competitive coder, I think the biggest thing that you need to do is how quickly can you write an algorithm? So most of the competitive things won't allow you to just use like a pathfinding crate, for example. So you have to say, oh, can I do Dijkstra's? Can I do A star? And you may have to do some crazy graph ones. So you're like, oh, I need to know, is it Floyd-Warshall that we've done before? Or, weird algorithms like that may solve very specific problems. Just knowing those are good. So, but also just getting the reps in, I think, is important too, right? Because a lot of it is finding constraints. So you say, here's my puzzle input. What kind of constraints do I have? What is like the brute force naive solution? And if it's only like 5 or 6 factorial, which we've seen in days before, brute forcing it is probably the fastest, and it's going to get you to the solve the fastest, even though it may not be the optimal. But there's other days where, like day 24, for example, my initial inclination was, oh, maybe just doing the brute force, we can like lower the constraints and brute force it, given those like minimal constraints. It's still solved in 15-20 seconds. I don't remember what it was, but there was clearly a better solution. And so understanding why that solution fits the puzzle may help. So anyway, those are all the things that are going through my mind. I'm sure I've talked ad nauseum about all this stuff, but it's a lot of fun to solve these problems, and I hope you're having fun too. And we'll see you next time. Bye, everybody.